All right, today we're going to talk about topic 9.1, which is the isosceles triangle theorem. We've already talked about isosceles, equilateral, and scaling triangles, but just a quick review over what an isosceles triangle is. An isosceles triangle is a triangle with two congruent sides. So, something to remember. An isosceles triangle has two congruent sides. Now, remember that that's what these marks on the side mean, these marks right here. If a triangle has sides with the same markings, you know that those two sides are equal. So just remember that's how we talk about congruence. Now we're going to talk about the big idea for today, which is the isosceles triangle theorem. So this is a VIC. This is a very important concept. So the isosceles triangle theorem, what that states is that if two sides of a triangle are congruent, then the angles opposite are also congruent. So that is the isosceles triangle theorem in a nutshell. I'm going to go ahead and give you an example that's going to explain that a little bit better. So what that essentially means is that if I have a triangle, let's just call it triangle ABC. This is an isosceles triangle, so we know these two sides are the same. We'll call this triangle A, B, C. So what this theorem states is if AC is congruent to BA or AB, we know that because of these markings right here. That tells us that those sides are congruent. So we know AC and BC are congruent. If those two things are congruent, then the angles opposite are also congruent. Then that means angle B is congruent to angle C. So if I'm looking at these sides and I want to find the sides that are the angles that are opposite the sides and I didn't know, all I got to do is draw arrows just like we always have. So again, if two sides of a triangle are congruent, so AB and AC are congruent, if I drew an arrow from this side, it points to angle C. And then if I drew an arrow from this side, that's also congruent, it points to angle B. So that's how you can find your two congruent angles if you can't just look at it and tell. If those two sides are congruent, then those two angles have to be congruent. That's what the isosceles triangle theorem states. Now that we have that, I'm going to go through a couple quick examples to explain how we would use that. So let's look at a simple example. So we're going to say we're going to find each angle. So we got an isosceles triangle ABC, and we're going to say that we know that angle A is 48. So we're trying to find angle B and angle C. Well, we know that these two sides are congruent. We know that AB, because of the markings, AB and BC are congruent. So that means the angles that are opposite are congruent, which means that angle B is congruent to angle C. So that's the first thing I'm going to write out, is I'm going to write it out in words. So angle B is congruent to angle C. Well, in this picture, they don't tell us anything about the angles. They don't tell us what they are. When we don't know something, we label it as X. So I'm going to go ahead and label these two angles as X. They're both X because we know they're both the same. We don't know what they are. Now, since I have something on all three angles, we know that from a ton of practice that all the angles in a triangle add up to 180 degrees. So I'm going to add these three things up. So that would be X plus 48 equals 180 degrees. Combine like terms, X plus X is 2X plus 48 equals 180 degrees. And now Now we're to a two-step equation. So the next thing we're going to do is subtract 48 from both sides. We know our 2x comes down. We know that that cancels, and we know that 180 minus 48 is 132. And then we divide both sides by 2, and we get 66. X is equal to 66. So now that we know that this is x, so we know angle B is equal to x, which is equal to 66 degrees. And we know that angle C is also 66 degrees. It's equal to x. And it makes sense because we know those two angles are congruent, which means they have to be the same. So that would be an example of how you do that. We're gonna look at one more. All right, again, we're going to find each angle. So for number 2, we're going to find each angle, and we're going to call this triangle PQR. And we know we're going to say that this is an isosceles triangle because those two sides are the same. So if we're going to try to find out what these angles are, we're going to say angle R is 86 degrees. So we're trying to find angle P and angle Q. So again, looking at this picture, the important thing is that we understand what the theorem is trying to tell us. We know that this is an isosceles triangle. So if I draw an arrow there, we know that angle. If I draw an arrow there and that angle are congruent. That's the important thing that we have to know. And again, I'm going to write that out in words. So that means angle Q is congruent to angle P. Again, in this particular example, we do not know what the angles are, so we're going to go ahead and label those X because we don't know what they are. And again, we're going to solve by adding these up and equaling it to 180 because we know the angles inside of a triangle add up to 180. So we'll take X plus X plus 86 is equal to 180. Combine like terms, and we got 2X is plus 86 is equal to 180. Now, simple stuff. We got a two-step equation. So the first thing I'm going to do is subtract 86 from both sides. That cancels. This comes down. 2x is equal to 94. And then all we got to do to finish this problem out is divide by 2 on both sides. And you get x is equal to 47. Now in this case, we know that angle Q is equal to x, which is equal to 47 degrees. And we got P is equal to x, which is also equal to 47 degrees. And it makes sense because we know those two angles have to be equal. So those are two simple examples. They'll get a little harder, but as long as you understand the gist of the theorem, I think it'll be good. I'll see you in class.